Welcome back, everybody. And now it's time to talk about something near and dear to my heart, high-performance housing. And we all know that we need to radically change the homes that we live in. And if we're going to meet those ambitious targets that we've been chatting about throughout the day. And, high-performance housing is definitely one of the ways that we can do it. So our next two speakers are leading the way in that field. First off, we're going to have Chris Weissflog of EcoGen Energy and Build. And following Chris, we're going to have Casey Gray of The Conscious Builder. Since founding EcoGen in 2006, Chris has been helping people reduce carbon emissions by designing and building solar thermal systems, grid-tied and off-tied solar PV systems, HVAC systems, and of course, passive homes. His clients include home and cottage owners, restaurants, businesses, community housing agencies, and universities. He's trained and certified as a passive house consultant in 2012, and he's also taking part in a multi-year association with Carleton University's Department of Engineering, exploring advanced concepts that integrate building and HVAC systems. By exploring synergies between building and HVAC systems, the project aims to make the next quantum leap in energy efficiency beyond passive houses. So without further ado, I want to bring in Chris Weissflog. Good morning, Chris, for your presentation.
Thank you, Nick. Great. Thank you very much for that intro. Just a few notes as we go along here. If you have any questions during the presentation, put them down in your chat. I'm going to log in later on and join you on that chat and give you answers via that means there. So I'll get to you after the presentation. There won't be any live discussion on this means. Having said that, if you have detailed questions and you'd like to talk more about those later, we are going to have at 4 o'clock the high performance housing room. It's a discussion room on this website. You can go to it via the agenda or the networking tabs at the top of the screen. That'll be at 4 o'clock, and we can talk tech at that time. Having said that, I can get, as you probably sensed already from the introduction, very technical. I'm trying my best to keep this at the qualitative level as opposed to the quantitative level, and trying to show more pictures than I typically do. This is a new thing for me. I'm just geeky that way. So having said that, I'm going to give you a presentation now that introduces in two parts. Number one, introduces the idea of passive homes. And then secondly, in part two, tell you a little bit about what our business is doing in that regard and in bringing that to clients. Before that, and sorry, once I'm done that, I'm going to hand over to Casey, who's going to tell you about his odyssey and and his offering as well in passive house homes. He's been doing a lot of work in the Ottawa region on passive. Okay, so having said that, what do we mean when we say passive homes? In a second here while I get into my presentation. There we go. So when I say passive homes, what I'm not talking about is there's not a real look to them. They could be, if you can see my mouse here on top of the screen, we got a couple of homes, look kind of modern. These are a couple of architects out of Quebec or builders out of Quebec. This house in the bottom left was Casey Gray's home that he lived in for a while. And he's got lived-in experience as I do, because this is my home on the bottom right. So a bit more traditional looking or modern, has nothing to do with the outside. Passive, really what it means in the passive house community is not active, meaning that we don't derive comfort in the building through active means such as hitting it with the big hammer of energy and big furnaces and air conditioners. Is really the envelope that delivers that comfort passively. And the other big misconception that we see a lot is that people think it means passive solar, whereas passive solar can be a component. On the design side, it's something we have to pay really, really close attention to, because in fact, the more sunlight you let in, the more overheating you can have. So in fact, it actually works the other way. Passive, again, being more the act of keeping the heat in as opposed to letting it in through the sunshine. So we can do that, but we have to be very mindful of it during the design stages. So again, passive is about not being active. If you can take anything away about what it means, that's really what the definition is. So where does it come from? Passive House Institute is in Germany, But before that, Harold Orr did some work here in Canada along those lines in the 70s. You see this building here really was an experiment in envelope design to bring you passive benefits without having to do a lot of active energy. And in fact, he went a step further, and as you can see, he had some extra solar thermal, but he's got good shading designs, and in fact, even insulated shutters. So some very advanced concepts here back in the 70s. Then in the 80s and 90s, Dr. Wolfgang Feist took over, really advanced the concept. He put it into a formula, standards that you had to achieve in terms of energy intensity, how many kilowatt hours of energy per square meter were used or per square foot in order to get through a complete year. So it's all based on an annual basis, as well as instantaneous the demand at a given time. So there are a lot of limitations set on it, but the idea was that we can get the amount of energy needed for a house or a building down to a very small amount in order to reduce the amount of energy consumed and reduce the carbon emissions, make our buildings more sustainable from an energy perspective. That concept made its way to North America and got institutionalized in the US via the work that Katrin Klingenberg and a number of other enthusiasts in the US had adopted it and began disseminating the German standard. Unfortunately, unfortunately, I would say fortunately, they discovered that the standard was difficult to apply cost effectively all across the various climate zones in the United States. We have some really cold climate and dry up in Alaska, and some very hot and humid climates down in, let's say, Florida and Georgia, and everything in between. So with all the different climate zones, they realized that if you were going to slavishly follow one standard, you might be spending a lot of money on one area when you could be spending it somewhere else, and yet achieving the same amount of energy intensity at the end of the day. So there was a parting of ways. I won't get into it, but what I can tell you is that from a fundamental perspective, they both agree that how you achieve high levels of energy efficiency is like this. You have, first of all, we got the thermal barrier, that's this insulation, keep the heat in, keep the heat out. Make it really airtight so that air and moisture don't work their way into the walls, but you don't lose air and the heat that goes with it, or the coolness that goes with it if you're in a hot climate. You optimize the amount of sunlight you get during the summer and winter. As you can see here, when the sun is low on the horizon in the winter, we can use the heat. We have good shading, keeps it out in the summertime. And of course, once you make your envelope really airtight, which you must do in order to prevent the air getting in and out with your air tightness, you bring in lots of fresh air and you recover the heat on the way out by giving the heat to the air coming in with a high efficiency ventilation machine. And lastly, you make up the heat with a small device. And I would tell you that in a case of homes that we've been building, 2,000 square feet, 3,000 square feet, about 2 to 3 hair dryers on the coldest night of the year. That's the amount of heat that we need to keep it going. In fact, we have a hard time finding heat pumps that are small enough. So what does it look like? Well, you've seen the pictures, but it's not so much what they look like, it's what they feel like that's important. It's all about comfort at the end of the day. And of course, the more efficient you become, the more comfortable they are. And I would say that comfort has a number of dimensions. In particular, the ones I want to draw attention to are thermal comfort, which of course we're used to because we have wide ranges of temperature here, plus 30 in the summer, minus 30 in the winter time. Yet here I am in short sleeve shirts, and in my house I haven't had the heat on in 2-3 days now. In fact, I'm cooling the house right now and making hot water at the same time. More about that later. But this is the kind of weather that my house likes. Sunny, because we do have some passive gain, and cold, because then the amount that we're losing heat, we're kind of gaining it up and gaining it at the same rate. So comfort, thermal comfort, we have humidity comfort, always keeping the humidity in the right range between 40 and 60% relative humidity. Indoor air quality, I mentioned the ventilation systems. So passive houses, because they have to be well ventilated, bring you fresh air all the time, get rid of the stale, humid, or toxic airs. I would say toxic, but you know what I mean. Airs you don't want to have in your house, and acoustic with the thick walls and the right insulations. you can achieve a high degree of thermal, acoustic rather, comfort here. I mean, I'm only 100 meters from the road, and the only thing I hear, or actually 100 feet from the road, are the Harleys that drive by and the big transport trucks and the knobbly tires. And even then it's small. And it's anecdotally, I think on the acoustic side, it's an interesting point. A lot of people will tell you that once they've moved into a passive house and they bring their fridge with them, the first thing they think is that their fridge is broken because it's making a heck of a lot of noise, when the reality is that they've now blocked out the outside world and they can hear their fridge for the first time. So, and last thing, the other idea of comfort that comes is peace of mind, because living in a home where the power goes out, your temperature might drop a degree a day. If the power goes out, there's no big worries about it coming back in time to run the furnace again. Same thing goes for if you're traveling and you're not going to be worried about your house. I've been away for 2 weeks in the wintertime, and our house went from 20 down to 13, and our heating never even came on. And of course, the energy bills that go with that. If your energy bills, I'll show you one later, but if your energy bills are for heating are about 7.5 cents per square foot per year, a 2,000 square foot home is $150 a winter. If it doubles, even if you're living on a fixed income, that's not a big deal, and it's not likely to double. So having said that, there's a lot of comfort in these homes, and what I'd suggest to you is that you actually get out there and experience them and do it. Kick the tires in the wintertime and in the summertime. Really feel them. So having said that, what do they look like, or what do they feel like? Here's some ideas. Talked about heating. Here's a cold climate air source heat pump. This is in one of our 2-story homes. We've got 2 heads on the inside that provide more than enough heating for the house. In fact, this system is oversized by a factor of 2 because it's the smallest thing we could get. Again, here's the other unit, and this is enough for, each one of these is enough for the whole home, but because there's not a lot of airflow between the floors, we had to have 2. Just to give you an idea, homes that are so efficient that the back room here, there's a bedroom with 2 outside walls, a window, and a ceiling. On the coldest night of the year, the body in that bedroom gives off as much heat as that room loses. Here's another one here, a small cold climate air source heat pump with a single head, 2 floors, but because they've got a big open to below area in the middle and a fan, they can mix it up and it can provide enough heating for the whole house. And that's a 3/4 ton or 9,000 BTU heating system, and it's more than enough for that house. And I mentioned how much it might cost to heat. Here is their energy use. In 1 year, they used under $1,200 worth of electricity, 6,000 kilowatt hours, and that's before the panels were connected and generating electricity. They were just being used as shading units. So $6,000 for the year for that house. That's all of the heating, all of the cooling. There's no natural gas, it's only electricity, and it's not grid-tied generating power. So what are the technologies you might find in a passive home? In the process, in the design, there's a lot of technology. I think I've covered a bit about that and a little bit more. And of course, in the build, there's some technology to ensure that their quality control is being maintained. And Casey's going to be able to tell you a lot more about that as well as a builder. So in the design, if you're doing a retrofit, you've got to watch out for thermal bridges. So that's a retrofit case here where we did some assessment of thermal losses through a masonry and concrete floor. And then some insulation. We're looking to see what the temperatures are at junctions to ensure that we're not getting condensation, mold, and mildew occurring. But of course, when you're designing new, you don't have to worry about that because you can design out thermal bridges. Here's a case in point, some details of a wall assembly, structural wall, Larson truss, all dense packed cellulose, proper barriers for vapor, for air tightness, for hygrothermal, which is the analysis, which is the movement of moisture and air through wall assemblies. Everything done right in this assembly here. No worries from any of those risks that are associated with poorly designed walls. And now that is a point to mention. Big assemblies like this with lots of R value can lead to a high degree of risk for mold and mildew. So when it comes to building them, the builder has to pay very close attention to the using the right materials and doing it the right way. So air tightness and vapor barriers, all that, and the selection of materials is very important. So what does it look like as we build? In a case for that last design, what you see here is a structural 2x6 wall with an OSB sheathing. You can see the joints have been sealed with a polymeric compound, and all of the extrusions out of the wall assembly, because we've got a Larson truss, these window bucks are all sealed as well, and then the windows will be sealed to them. So we've got continuity of all of our barriers, and of course all the nail heads are sealed as well. We then cover, and you will see this with any design, the exterior surfaces, good for vapor passage, in this case using fiberboard and very vapor permeable materials like the fiberboard and the Tyvek for the bulk water resistance, and dense packed cellulose in this case here. On the inside, you've got your structural with your footings for posts to support the upper floors, all on high density foam for load bearing, and our vapor barrier and air barriers coming around that. Again, attention to details, a layer of styrofoam perhaps, and then a barrier sealing off the plumbing under the floor, and then more barriers, of course, and all that's protected by another layer of foam. But you can see how the continuity is really important. All of the barriers are connected, and those would connect to the walls as well. And for attic hatches, here's an example of an attic hatch plug, because with R100 in the attic, you've got 2.5 feet of insulation, you got a big tunnel, and so you got to plug that and provide some thermal protection. In this case here, a plug with some flanges to prevent air cycling up and down around it, even though the tolerances are fairly tight. And of course, when you're building, you've got things like air testing. Here you've got minus 50 kilopascals reading for 2,000 square foot home, 63 cubic feet per minute through the door, which tells us that this house is reaching 0.3 ACH50, which is the limit for passive house is 0.6. So this one is twice as good, I guess you would say. And typically in a passive house, you're going to see the high performance ventilators with dedicated ducting, taking air to all the rooms, exhausting air from bathrooms and kitchens and other rooms. In this case here, not standard, but is a ground loop preheating of ventilation air. Here you're seeing again the stuff you've seen earlier, the cold climate air source heat pump. Here, domestic hot water provided by another heat pump, a heat pump water heater, which takes heat from the home and supplies that heat to the water to heat the water. It's great in the summertime when you can benefit from the cooling, and you can benefit also because it cools the air and provides the cold air back to the house. The air's also been dehumidified. So you've got that extra benefit, getting 2 for 1 out of that deal there, and also making your hot water at about 3.5 times more efficiency than using just electric resistance. So really beneficial, especially in a passive house where the heating season is really short, because you can go a long time into the fall, still be cooling, and even in the wintertime cooling in order to make hot water. And lastly, drain water heat recovery. You're going to see that a lot as well, where the hot water from the shower, the drain water is coming down, and it's being used to preheat the water for the domestic hot water. So having said that, as I mentioned earlier, using all electric, if you have an opportunity to connect to natural gas, it's not worth it. With a small electric bill like that and the small amount of energy you're using for natural gas, you're not even going to make the savings up on the connection charges for the monthly charges for natural gas. So don't even go there. We can make heat with heat pumps more efficiently than natural gas and more cost effectively. So what is it that we do? You've seen quite a lot. You've heard we did solar thermal. We not so much anymore. HVAC design capabilities, PV, off-grid, grid-tied, passive house design, and 2014 got into passive house building. And here you see basements, a lot of things going on that we've done. Our approach has always been on sustainability. So when we started off, we selected materials and designed everything around an approach that used sustainable materials. So we're using cellulose above grade for insulation, wood as much as possible because that's embodied carbon, and that's embedded carbon rather. And of course, try to make it local and affordable as much as possible. And so all of our assemblies were designed around skill sets that were readily available, just required minor tweaking. And lastly, affordable. Key thing here is that if there is a small premium associated with building to the passive house level, the energy savings and the savings on the money on your energy bill, when you put them against your mortgage, more than makes up for the difference. So when people ask me, what's the payback period, and I tell them that there isn't one, it's immediate, often they don't get it. But if you think of it as building a code home or a passive home, pay a little bit more here, but roll them all into mortgage monthly bills, and you're equal, and right away out the door, you're on an equal footing, but in a better house. So having said that, what's it look like? Here, typically our foundations but are 50, our walls are 70, our attics are 100. We're using PV shading wherever possible, and to give us shading on the lower floor windows and our eaves on the upper floor windows. We're using high performance UPVC windows and doors, and we're building them all net zero ready with reinforced roofs, and all the conduits and everything in the right place to make it easy, plus gang planks or catwalks in the attic over top of all the insulation. And lastly, when you open the doors, you can feel the air tightness. So standard are the cold climate air source heat pumps, the heat pump water heaters, the drain water heat recovery. We can and have been doing the ground loop preheating of the ventilation air, which gives us a warmer air when we supply it to the rooms. And of course, one of the things that we found very beneficial is that with a house that's so efficient and requires so little energy to run, for the extra $1,000 for an extra load center or breaker box with a transfer switch for a generator and a generator connection on the outside of the house, you can plug in an 8 or 10 kilowatt generator and have everything that's essential: your heating, your hot water, your well pump, your ventilation system, your lights, your internet these days. Anyway, it's not a big expense to be, and burn a little bit of carbon, yes, but that's well hydro isn't providing for you. And then lastly, of course, we're doing typically slab on grade and garages with uninsulated garages with a loft for storage, because all of the area inside the insulated house is high premium, and you want to have a little space for your spillover. And a lot of things can be stored in a garage. About 95% of our things do not need to be heated. So, and lastly, entry level might be vinyl and aluminum trims, but we are doing a lot of fiber cement as well. Or steel, and some nice sidings as well here. So advanced features, the awnings, the grid tie, a little bit of extras here, grid interactive or off-grid systems. Those are all things that we can do and have done. We've done some radiant floor, we've done basements, we've designed in greenhouses. Didn't go forward with this, but the key thing about greenhouses is understanding that space where they're connected to the house, because those walls have to respect the hydrothermal dynamics of the greenhouse as well as the house and not deteriorate. So some advanced features there. Also root cellars integrated in, cisterns integrated in, storage, masonry heaters integrated in. Two things here: air tightness and thermally overwhelming the house. Did a lot of work on this. It is doable with some caveats. However, again, this is a case of what the client wants. You do your best, and in this case here, it was doable with some caveats, but we were able to respect the air tightness, I believe, or would have been able to. Hydronics, interesting. Join me at 4. I'll tell you more about this. My place, I use a ground loop without the heat pump. I can cool my house with using just the hydronics. $14 of electricity per summer. Keep my house closed down for 4 months, 21 Celsius all summer. And that's just using ground loops and hydronics. Thermal energy storage, large reservoirs built in, an advanced heat pump system that does everything, making hot water, cooling the house, dehumidifying, heating the house, getting rid of heat, everything. Anyway, that's a subject of study, a PhD student at Carleton University, as well as we're our 3rd year in running with some undergrads. And lastly, lest you think we're only technical, we also, of course, do all the niceties here. You see a bit avant-garde. We've got some concrete floor going on, got some really nice cabinetry with a close association with a custom cabinet worker, some more traditional looking materials here and here, indoor finishes with wood. Love that sort of stuff. If you join me at 4, we can talk a bit about this, which is the challenges of bringing Passive House to the community. Largely, I'm talking about the lack of support from a lot of engineering, and very mainstream engineering, very mainstream building departments. We're pushing the limits and trying to work with them. I mean, we have a lot to learn, but they, and they've got their jobs to do, and they've got a lot of people who are cutting corners, and here we are trying to build up the corners. So it's a very interesting experience. More about that at 4. If you join me, here are some links. I can cut and paste those into the chat channels if you're interested. And back to that, if you want to join me again at 4 o'clock, I'll be available at this showcase room here. Go to the agenda, networking area, either one of those tabs at the top of your screen, and I'll join you there at 4 p.m. So I hope that you found this beneficial. I look forward to your comments or your questions in the chat. If they're really detailed, I'm probably going to ask you to join me at 4 o'clock, because if you're getting me going technically, that's at your own risk. Okay, much appreciated. Thank you for your time and interest, and look forward to talking to you in person.
Thanks so much, Chris. Great presentation. You really fit a lot in half hour there. Well done. I want to thank you so much for really pushing the high performance housing. I've been to one of your builds. They're quite incredible. When you step in, you know that there's something different about the homes that you build. So congratulations on that. I know there's a few questions in chat that people are wondering. So Chris will be heading over there and chatting everybody. And then also, as he mentions, he's in the 4 o'clock high performance housing networking room. So excited to head over and see you there as well. Chris, thanks so much for your great presentation.
Oh, you're welcome. And good luck there, Casey. Enjoy Casey's presentation all.
Absolutely. Yeah, so next up we do have Casey Gray. So just stay tuned for a couple minutes, and we'll come back and we'll introduce Casey. We'll get him all set up. Welcome back, everybody, and we're going to continue talking about high performance housing. And of course, we couldn't talk about high performance housing without inviting the Conscious Builder, Casey Gray. They've been doing some great stuff in the community. If you don't know them, definitely head over to their social media. They've got a great YouTube channel with so much different content. So if you are looking at building a home, that's a great place to start. Casey really details a lot of stuff. They've got a great project coming up called the 3-Day Cottage. I think it's a web series that's going to be coming. Lots of different stuff on their social media channels. So definitely worth looking at. So up next, we do have Casey. Casey brings almost 2 decades of experience to the construction industry and over a decade of experience to running, owning, and growing multiple businesses, including the Conscious Builder. While also staying committed to his wife and son. That's very important. Casey is on a mission to help people build homes, businesses, and lives in a more conscious manner. So without further ado, I want to bring on Casey, and just a reminder, he's going to do his Q&A over at the Conscious Builder exhibitor booth. So if you do have questions for him, just head over to his Conscious Builder exhibitor booth after his presentation, and you guys can chat about high performance housing. Thanks for joining us, Casey.
Yeah, thanks for the nice intro, Nick. And Chris, before that, actually had some nice words. I really appreciate that. And I switched up my presentation kind of last minute here. So I'm not going to get into passive house like what Chris did, but all the concepts that I'm going to discuss really come from the experience in built, which started with building our first certified passive home about 7 years ago now. And what I'm going to focus on today is more on the renovation side. And the reason why I want to do that is because obviously we're all in these interesting times, and there's more and more people wondering what to do with their home, and because we're all working from home now. And so I think it's important to focus on healthy, comfortable, and efficient homes. And that's really what we're about here at the Conscious Builder. It's a little bit about myself. Nick already said that in the intro, but here's a few pictures. Husband, father, adventure seeker, carpenter by trade, entrepreneur. We have a podcast, and we have our YouTube show as well, which we do a lot of exciting things on. We have a lot of really cool projects on. And I'm going to speak about a couple of our cool renovations that we have on right now that are not ordinary. I don't think we do any ordinary projects by any means, but you'll see when I get into it. And one of the questions that always comes up is, why conscious? Why did you call your company the Conscious Builder? And to me, like, consciousness is really just being aware, right? So it's being aware of the decisions, how your actions will have an impact, whether they're positive or negative, and then whether they're on yourself or beyond that. So that's why we go this way. Our role, what we see is we want to raise people's consciousness when it comes to building healthy, comfortable, and efficient homes. And that's what we're here to help with. And there's a lot of great people out there that can help you do that, but it's about knowing what's possible first. And if you don't know, you don't know. So that's what we hope to help with here. So, once again, Chris touched a little bit on this in his presentation was comfort, and there's different aspects of comfort. I'm really going to speak about the thermal comfort that Chris had mentioned. So what is a comfortable home, or how do you build a comfortable home? So it's super insulated exterior surfaces with limited or no thermal bridges. So thermal bridges, meaning somewhere where there could be a high heat transfer area. So if you have anything, like say there is a piece of wood or metal or anything that went from the outside of the building to the inside, that would be a thermal bridge. You want to break that as much as possible. You want high-performing triple glazed windows. You want proper building orientation. You want properly sized overhangs, and you want to make it as airtight as possible. And then make sure that you are implementing a fresh air system, or an HRV or an ERV, which I will get into as well. Now, one of the things that comes up is obviously you can't do all of this in a renovation. I understand that. Your building is oriented the way it is. Your overhangs are typically the way they are, unless you're going to do a whole exterior renovation, which is something that we are doing on a home, and I'll share. But there are other things that you can do. But the one thing I really want to stress is that if you're looking to improve the performance of your home, or the comfort or the efficiency of your home, it's easy to go after the low-hanging fruit. And if you get an energy advisor in and they say, oh yeah, if you change your furnace, you're going to save so much money, that's great. But that's not going to improve your comfort of the home. By changing your furnace, you might save some money, but at the end of the day, your home is still going to feel the same as it did before. And then if you do any upgrades to your envelope, your furnace will be oversized. And most people's furnaces are oversized and they don't realize it. I actually just had this conversation with a neighbor of mine, and they moved into a home. They had a cold room in their house. They actually installed a second furnace, and they still have issues, right? But even some of these HVAC companies don't know, because they haven't been taught either, right? Or maybe they're just trying to sell equipment. I don't know. I can't really speak for them. But if you do things in the right order, you will have a much better product. And that's what's called an integrated design process, where you have all of the people involved together from the beginning. I'm not going to pretend that I know everything. That's why we work with architects and designers. That's why we work with consultants. That's why we work with energy advisors. That's why we work with the homeowner, because we all need to be at the table making decisions together. That's a big part of what we do, both in renovations and all the custom homes that we build. So the thing that I really want to focus on in terms of comfort is air sealing. And the easiest way to explain how important air sealing is think of today. You wouldn't go out on a day, if you're in Ottawa right now, it's cold out. It's been, the last couple of days have been cold. You wouldn't go outside without zipping up your jacket. That is essentially what air sealing is on your home. You want to zip up that jacket. It doesn't matter how thick your jacket is, how much insulation you have in your walls. If you don't have that windbreaker zipped up tight, all that wind's just going to flow through, and it doesn't even matter. It might slow it down a little bit, but if you don't believe me, go outside right now, stand towards the wind, open up your jacket, and let me know if you're warm or not, and whether or not that jacket's helping. This is the best analogy we can give when it comes to air sealing. And then the other thing that often comes up when I talk about air sealing is, well, what about the home, and doesn't it need to breathe? And my answer is yes, it does need to breathe. But here's another analogy. How do you breathe? How do you personally breathe? You breathe through your lungs, right? You don't breathe through your skin. So you breathe in through your nose, your mouth, and technically you breathe through your nose. It kind of filters the air, preconditions the air before it gets into your lungs, and then you breathe out the bad stuff. That's what you want your home to do. You don't want to be able to breathe through your skin, but you do want to perspire through your skin. In the case of a home, you want to make sure that if there's any vapor in your walls, it can travel through, right? So it can go, that's what in construction we talk about permeability. So we want to be able to allow that vapor to travel freely through it, but not the air. We want our skin, our envelope, to be airtight, and then we want to control the air that comes in and out of the building. And when it comes to these problems, I'm sure you've seen, especially on old houses. This probably looks fairly familiar. Maybe you're not, hopefully you're not out there with an axe trying to chip the ice off of your roof, but this is not necessarily the cause of this isn't because of insulation necessarily. It's usually because of air leakage. And there's lots of ways that air can leak out of a house, but I'll get into the difference between vapor barriers and air barriers as well. So an air barrier, if you look at the code, it's actually required for an air barrier to be continuous as per the Ontario Building Code. In theory, that makes sense. In reality, that's actually impossible and has never been done to my knowledge, because if you had a completely 100% continuous air barrier, you would have an air change per hour, ACH, which Chris talked a lot about on his presentation, of 0. That would mean that you wouldn't have anything going through your wall, but that's not possible. Well, hopefully it will be possible one day for homes, but for the most part, if you're getting low, like below passive house levels of 0.6, that's extremely airtight. That is a really good target. Chris mentioned 0.3 on his own. That's amazing. That is what we're aiming for. The vapor barrier, however, does not need to be continuous. And why I think there's a big confusion with this is the way most people build and renovate homes right now, they use the 6 mil poly, which is on the inside of the studs typically. So you have, most people understand that there's a 2x6 wall and you have some insulation in there, and then you have some poly and then your drywall. That poly is used as an air barrier and a vapor barrier, but people have been calling it a vapor barrier forever. There's technically 3 barriers to a home: a weather barrier, a vapor barrier, and an air barrier. They can all be the same thing, or sorry, the air barrier can be with the weather barrier or the vapor barrier, but it could also be separate. So the vapor barrier has to be on the inside. Weather barrier obviously has to be on the outside. The air barrier can go anywhere in that wall assembly. And that's why there's a bunch of different ways to do this. And what's important to understand, especially when we get into renovations. So how do we make this work with old houses, right? There's a lot of old houses. The thing why I wanted to focus on renovations as well is because there's a lot more homes that need to be renovated than homes that need to be built, right? There are always going to be more older homes on the market because there's only so many new homes that we can build and only so many new homes that we need every year, but the old homes will always be continuing to rise. So here's, I want to share a little bit of a project that we recently just started. So I don't really have any finished pictures yet, but this is a home that we're going to be renovating. So this is a stone home built in 1860 that is probably the leakiest house we've ever tested. This came in at an air test of 11.7 ACH, which is wild. I know those numbers might not make sense to some people if you don't understand the air changes per hour, but essentially, I believe we had, if you were to break that down into the size of a hole in one space, I think there was 680 cubic inches or something like that. And basically, a hole that big is what it would equate to in this house. Of air leakage. But what we're aiming for now is, obviously they hired us because they want to improve the comfort. And this is an old stone home. We don't want to do anything from the outside. So we're doing a lot of work from the inside. And as part of that, I'll share some numbers that we have, but right now they technically need about 143,000 BTU furnace to heat this home. By the time we're done, we're hoping to get it down to 50 or less, 50,000 BTUs or less, which will be significantly less. More if we can. It kind of depends on. It's a budget game as well when we do renovations. You know, where do we focus all of the or some of the efforts, and sometimes we can do it in phases. One thing I really want to stress, as I said at the beginning, is air sealing. So to give you an idea of how much just focusing on air sealing would do in this case, if we were able to get it down to 1.5 ACH, which is a requirement for the new CHBA standard of net zero buildings, if we only focused on airtightness and did nothing else for the renovation, we would be able to reduce the heat loss. So the gigajoules per year in terms of heat loss would drop from 314 to 74, which is about a 76% reduction in heat loss. And that's only if we focus on airtightness and did absolutely nothing else. If we didn't add any insulation to anywhere, if we didn't change the heating system, we didn't do anything, just airtightness. So this gives you an idea of where's the lowest hanging fruit. Obviously, this is not a cheap thing to do or an inexpensive thing to do, I should say. But it is the most important thing, because not only will this improve the performance of the home, it will also improve the comfort. And that's what it comes down to. If you're, at the end of the day, if your home is not comfortable, you are going to be turning up the heat, right? If you are going to be turning up the air conditioner in the summer, you want a comfortable home, and air tightness, can't say this enough, is what is one of the most important things when it comes to comfort in a home. And to go a little bit on the acoustic side too, that Chris touched on, is sound travels through air, like through cracks, right? So if your home is, the more airtight your home is, the quieter the home will be, meaning that the outdoor sound won't be coming in. So if you're in the city and you have a nice tight home, you won't hear those trucks going by as often. I've been in passive houses. We did an ICF passive home for another Chris Straka of our design, and he's almost right on the road where they're digging tunnels, and there's dump trucks driving by, and you can't even hear the dump trucks when they come beside his house. It's wild. But that's partly insulation, but also airtightness. Now, in this same home, if we go to the overall energy consumption, if we are able to get it down, once again, only focusing on air tightness, we could reduce it from 367 gigajoules per year. So this is all of the energy for the entire home, down to 65, which would give us about a savings of 82%. Once again, air tightness only. Now, the reason why this is different from the other one is strictly focusing on heat loss. This will take everything else into consideration. There's going to be air conditioning as well. So the way we're going to do it in this house is we're really focusing. I can go back to the picture. These walls are about 2 feet thick, stone right through. We are going to do an air barrier on the inside. We'll post pictures. If you follow us on our YouTube channel, we'll be sure to post all sorts of pictures and videos about this, and we'll keep people updated. That's one of the things that we love to do on our YouTube channel, is to showcase what we're doing, why we're doing it, what's working, what's not working. And this one is exciting because we haven't been able to do it on a stone home before. So it's we're going to be trying a couple new things. Obviously, we've done our research, but we haven't had the opportunity to do them yet. So we'll focus on inside. We will be doing a liquid applied air barrier on the stone, and then which is permeable, because we want to make sure that it can breathe, the vapor can travel through it. And then we're only going to be adding about R24 worth of stone wool insulation, so rock wool insulation. And then we'll upgrade the insulation in the attic. We'll also improve the air tightness there. And there's conversations to be had about what to do in the basement, because it's a dirt floor crawl space. And we know that we're losing a lot of air through the floor potentially. So it was basically a wind tunnel through there when we were doing the blower door test. Pretty wild. Now, another building I want to show is one that we started a little while ago, but it's still underway. This was a brick home built in 1920. So once again, it's not wood frame like most houses in Ottawa. This was 2 layers of brick, and the back addition, if you can see my cursor on the back part, this was actually done in 1940, this addition, but this was block addition, and they have brick on the front of it. So this was a little bit tricky, and has been tricky because it's actually in the city. So you can see how close the neighboring houses are. There's one here, there's one on the other side. And we decided to do everything from the outside here. So when you get into adding more insulation, you have to think about how that affects the building. With the stone, that's going to be a lot more, it's going to be able to handle the freeze-thaw cycles that we live in. Brick can be a little bit different. So if we were to do this building from the inside, for one, they'd have less space on the inside, so it'd make the home a lot smaller. But two, the brick partially lasts as long as it does because of the heat loss that the building had. So it dries it out in the winter. If you were to block all that heat from getting to the brick in the winter months, that brick would eventually start to crumble because the moisture would get into it. It wouldn't be able to dry, and then it would freeze, and then it would start popping the bricks. So in this case, we've actually decided to go on the outside and essentially take that whole jacket concept that I talked about at the beginning and wrap the whole house. So backwards there. So here you can get an idea of what we've had to do. It's been some interesting framing. I'll show another picture, but everything had to be foam over the roof. We decided to spray foam the walls. Foam is obviously not the greatest for the environment, but for this product, it was partly, or this project was partly on cost, but partly on the strength that we wanted, because a lot of the brick was falling apart. By spray foaming everything together, it was actually going to hold everything together, and the homeowner felt a lot better about that. And this is a shot from above. You can see how we had to frame and actually level the roof because the roof had a big dip in it. So you can't tell from this angle, but if you were to stand at one end and look down the other, there was probably about a 4-inch dip as the roof was pretty much waving at us. And the guys did an amazing job, got all the insulation on there. I believe, if I remember correctly, we have about 6 inches of XPS up there, and then it's all taped and sealed. So this is going to be our air barrier as well. So we've taken the air barrier and we've put it on the outside with the weather barrier. This gives you an idea of how we've had to frame it. So this is the front window, which was removed, and then everything had to be strapped out and nice and plumb as best as we could in this case. And the spray foam was going in between that. That gives you an idea of what happened after. And that's why we had to tarp it too, because we get into colder weather. So we need to make sure that we had some heat stain in there in order to make sure the foam would cure properly. And this is basically where we're at this point. We're actually a little bit further. This is the back of the house. You can see the steel roof is on now, and that blue tarp you see at the bottom of the image is actually that old addition that we were that I was talking about that was put in the 1940s. We just started to renovate this portion, and these big beams are now put in place that you see. That was all put in on Friday. So it's moving along nicely. And the trickier thing with this one is that, well, they're a little bit different. So this one, because we're tackling it from the outside, the homeowner's been doing a lot of the work inside himself. They've been living in the house the whole time. The other home where we're doing it from the inside, we're gutting it. So they've had to move out for 6 months. And that's the only way we could do it. There's no other way that we could renovate the inside of that house. We had asbestos to deal with there as well, which I believe we did here as well. So that's common in a lot of these older houses. Now, the other thing that makes a house airtight is the windows and doors. And just pulling out my other notes here. You don't have to go out and get passive certified windows and doors necessarily. Like that is often a requirement for getting a certified passive. Not necessarily, you take a hit on the modeling, but you do need to understand what makes a good window, because windows will range widely in prices. We got quotes for our passive, I think they range from $70,000 to $140,000 and at the time, and we probably could have went higher, but that gives you an idea of how much the windows and doors can be. A lot of the European certified passive house with tilt and turns, they can get extremely pricey. That's exactly what you're looking at here. This is a expensive European style window, but you can see the seals that it has and how much attention to detail there is. Now, aluminum clad wood windows are probably some of the most expensive windows that you're going to be able to buy, but you can get a good performing window made out of PVC if you're okay with PVC. We do, on the cost effective side of things, we've done a lot of windows with North Star. They perform well. We haven't had any issue with them. Obviously, service is a big thing for us when it comes to working with products. So we want to make sure whoever we're buying from, if or when there is an issue, that we can get good service. And not a lot of these companies have the service available within Ottawa. If you're ordering overseas, who's going to service that if something were to happen? That's always the tricky part in our position as a builder, as nice as some of these products are. But to understand a window, so you want to make sure that you have, like when we're talking triple glazing, the glazing is going to be the glass, whereas the coatings will be like the low E coatings that would be on the inside of the glass. And the spacers in between what you want is super spacers. So you don't want aluminum spacers. You don't want an aluminum frame that goes all the way through. You can have aluminum clad on the outside. Sometimes, like, we get into commercial windows for strength sometimes, and it's going to be aluminum. That's going to affect comfort when you're standing close to that window. You just need to understand. So a big thing for comfort is you want to feel warm, right? You want to feel comfortable. And if you've ever stood by an old window, even if it's just double glazed PVC, actually probably on a day like today, you could stand by that window. It would feel like there was a breeze there, but you wouldn't actually have a breeze. It's just the convection current. It's because the glass is getting so cold and it's hitting the warm air, and then it's creating this convection current, and it feels like your window is leaking. If you change that to a triple glazed window, a decent triple glazed window, that would be eliminated for the most part. Maybe not completely eliminated, but it'll be a lot better than the double glaze. And I can actually speak where we are right now. We had changed it from a double glaze to triple glaze. We didn't go passive house or anything like that, but there was a couch right by the window. In the winter, you'd have to close the blinds. Once the window was changed, it was fine. You wouldn't feel that on the back. I don't have my chair. As you can tell, I could feel it on the back of my head. Now we're totally fine. This gives you another idea of seal. So if you have a window that's open, you want to make sure that it's going to be able to seal properly, because the sealing, like the windows and your doors of your home, are essentially the weakest point of your wall assembly, of your envelope. So you want to make sure that they're sealed properly. And you can see in this picture, they've obviously put a lot of attention to detail into their seals. Now, one more thing, last thing I really want to discuss is, okay, what happens? Now you've made my house airtight. Now what? Now my house can't breathe. How do I get fresh air into that building? This is the ERV and HRV or HRV that Chris had mentioned before as well. Now, a lot of companies, HVAC companies, people will say that, well, you can't use ERVs, you can't use ERVs in our climate. That is not true. You can use ERVs in our climate, and they're actually better. And most people think they stand for energy recovery ventilator. It actually stands for enthalpy recovery ventilator. Enthalpy is the transfer of moisture. And that is what we actually want, because we have cold, dry winters, and we have hot, humid summers. So we don't want that moisture to be coming into our houses when we don't want it. So this picture is from our passive house. Air Pahoda doesn't make this. I don't even think Air Pahoda is a business anymore. But this is an idea of an ERV. What you'll see on the left there is we just had to have a pre-duct heater, which a lot of the models don't need anymore. So there's all the North American companies are now making ERVs. And that would be what we would recommend, because you can control humidity with it, but you won't necessarily be getting rid of the humidity that you want or taking on humidity that you don't want. Whereas an HRV will do that, because you can't transfer any humidity through the core. I won't get into all the technical reasons of how this works, but once again, if you have any questions about any of this stuff, I'll be at my booth. And we can get, similar to Chris, we can talk more technical details if required. But this is essentially the lungs of your home, right? This is how you want to control the air coming and going from your home. You don't want it to be leaking through your walls. You don't want to, have to open a window, because if you open a window, that's only ventilating maybe that one room. It's not getting everywhere. A properly installed fresh air system will be ventilating your entire home, and it runs 24/7. And to give you an idea of how much heat loss you could have in a home, a lot of people love these big range hoods, right? Or even a bathroom fan. When you have a properly installed ERV system, that's a completely dedicated system, you can get rid of all of your exhaust. You don't need bathroom fans. You don't need a kitchen range hood unless you have a gas stove, because then you need it for code. But we get into other issues if your house is too airtight with fuel burning appliances. We won't get into that right now. But this calculation gives you an idea. If you put in one of those big fancy 1,000 CFM range hoods and you decided to run that range hood, just think of where the air is coming from. If it's minus 25 degrees outside and you start running this range hood, it's sucking the air in from somewhere. It's sucking in through all the holes in your house. So if it's minus 25, that air that's coming into your house is minus 25. It's not getting preconditioned by anything like it would in an ERV system. It's just minus 25 coming into your 22-degree home. In this case, if you were to run it, it shows you will be losing almost 89,000 BTUs in an hour. That's heat that you have to make up for when you're running that fan. So obviously, maybe you don't have 1,000 CFM fan, but even if you cut that in half, you're still losing a lot of BTUs. These homes, like the house, that the certified pass one that we built, we only needed 18,000 BTUs to heat the entire home. The houses that we're renovating, the brick home will only need 20,000 when we're done. So this gives you an idea of how much heat loss you're losing. Once again, it's all about air tightness. So in summary, air tightness is the most important part of a comfortable home, in my opinion. But you need to understand the difference between an air bearer and a vapor bearer. And if you're working with a contractor, make sure that they understand the difference between those different barriers. Make sure your home can sweat, so to speak, but this is the permeability, right? You don't want to trap, when you get into thicker walls, you want to make sure that you can get rid of moisture that will inevitably end up inside of that wall. And then you want to make sure that your home can breathe through a set of lungs, which is an ERV, but not through the skin, which is the envelope, which is what we talked about. So once again, I'll be at my booth if you want to come chat with me there. We have Sean working the booth there as well. You can check us out on YouTube, but you can also find everything on our website. And I look forward to meeting you in person, or at least virtually seeing your face.
Thanks so much, Casey. Great presentation. Yeah, it really is all about air tightness, and amazing work you guys are doing at the Conscious Builder. Been following you guys for a while. Really invite everybody to head over to your YouTube page, head over to your social media links, your Facebook, lots of stuff going on there, lots of great information. I'm excited to see the 3-day cottage and how that goes, and just to continue to watch your journey on the conscious building and all that kind of stuff. So thanks again for joining us, Casey.